for the final. Okay, so let's see what we did. So we talk about the definite integral, remember the other day? So that make easy for us. So if you see the integral from 0 to radical pi, this is the square root of pi, this is going to be definite integral. The definite integral was the one that we started with those partitioning the method, the Riemann integrals. And we introduced this definite integral as a number, and we give you the fundamental theorem of calculus to find it. In order to find it, so you are going to find the antiderivative of the function. You have the power rules to apply, or you may have to use the substitution method. And then at the end, you are going to evaluate it for those two numbers. The result is a number. That number depends on this function, would mean something. If this function is going to be a positive function, okay, you may talk about the area under the curve. But it may use for probability, okay, in this case, and you will see another applications today. Okay, so you don't have to use the definition, but we give you one that you have to use the definition on this test and on the final. Okay, and we practice it tomorrow. So we are going to continue getting some properties of this integral. Okay, so we call it definite integral, or to honor the creation of this topic, Riemann. Sometimes we call it Riemann integrals. Okay, so this is just a combination of the leftover of the sections, mostly section 4.4. Okay, so this is, I just put the date for the lecture notes that I post. I've already posted all your lecture notes. So if you miss any class, you better check those. Okay, that's it. So we are going to be in mostly in section 4.4. Okay, it's any leftover that you have. So we are going to talk about the properties, the rules, properties of this new integral of definite integral. That's the one that's used mostly in science. Definite integrals. Okay, we go with the notion of the definite integral, but some people like this name, Riemann integral, in case you see it somewhere. Okay, but definite integral. We're going to talk about it, you know what we are talking about. So the first property is going to be existence of this integral. If your function is continuous, this integral can be done all the time. Okay, so it's guarantee. So if f, f is continuous, f is going to be continuous on this, it's a continuous function on a closed interval of a and b, then this integral exists. Then we say that f is, okay, as we talked about the other day, is integrable. Integrable means you are going to be able to find the integral. Okay, integrable, and of course, this means this integral from a to b, f of x dx, this integral always exists. Okay, so we are not going to be worried about it. Of course, this theorem can be extended to the piecewise defined function, and we're going to do it in a minute. Okay, so this is one property. It's not difficult to prove, but we don't usually prove this one. So that would be property number one. So that's guarantee. All the functions that we use are mostly continuous on this interval, and like the polynomial rational functions, everything. So we didn't have any difficulty. Okay, in calculus 1, we stay with this one. But in calculus 2, we extended a little bit. That's the first condition. The second one, if this function is continuous and is also positive, then this integral can be interpreted as the area under the curve. Okay, so if f is going to be a positive or a non-negative, it is a positive, because when we talk about the area cannot be a negative number. It's the same for the probability. Okay, so if f is a positive and continuous, okay, continuous function, it's going to be continuous function on this closed interval a comma b. Okay, then as we create this one, then a equal to the integral of a to b f of x dx. Okay, then this can be considered as the area under the curve. So this is going to be is the area. That's the one that you solve the area problem for it. Is the area of the region. Okay, the area of the region under the curve, or sometimes we describe it enclosed, bounded, enclosed by the graph. Okay, enclosed by the graph of the function of y equal to the f of x over the interval of a comma b. Okay, this is the one that we did, but we summarize it here. So in this case, this means if this is going to be the graph of the function, okay, and it's defined between a and b. So this area here is going to be, can be defined by the definite integral. A is equal to the integral from a to b f of x dx. Remember previously we used the Archimedes partitioning one and we find it, but now we can use the definite integral to find it. Okay, any question? Now, the following are going to be the one that from time to time we are going to use. So I'm going to use, this, if I circle it here, so this means you are going to use it quite a lot or to remember it. From time to time, since this integral is the abstract number, okay, so you may have to find or answer this question, what is going to be integral from a to a? Okay, a to a f of x dx. You see this a to b is going to be referred to it as limits of integrations. So this means this is going to be the domain or the interval that we're going to integrate in. But from time to time, mathematically, we may have to check this one, a to a f of x dx. Just be using common sense to see what is going to be this one. You see, if you consider it as the area under the curve, in order to create the area, you have to move to get it. If you move from a to b, then you are going to create a region, and then you are going to find the area of that region. But if you don't move, you won't get anything. So it's wise to introduce this one or to define it to be equal to the zero. Okay, so we have enough justification to believe that this must be zero. Okay, so anytime you see it, you're using this fact, and in order to remember it, you just remember you don't move. If you don't move, you don't have any area, you don't have any partition, so everything would end up with a zero. So the integral from 2 to 2 is 0. Integral from -1 to -1 is 0. Okay, so this is one property that we're going to use when we're dealing with calculating this integral. Any question? Now the next one is this one, which is going to be very important for us. You see, anytime we write this integral, this lower limit, we call it, must be smaller than the top. So we can talk about the integral from 2 to 5. You can talk about the integral from 1 to 3. But sometimes you may like to talk about the integral from, for example, 10 to 5. So if it's going to be 10 to 5, this means you see the direction that we pick. If it's going to be 5 to 10, it's going to be the usual direction from left to right. But if you get 10 to 5, it's the opposite direction. So the opposite direction, if you compare them together, means you have to have the opposite number. So if this is going to be originally, if this integral is equal to the 5, if you switch the bound of the integrations, so your integral must be opposite of the 5. Opposite of the 5 would be -5. This would be used, especially we are going to introduce one case that use it nicely is when we are going to introduce the notion of the natural log. And we need it from time to time. Okay, although it's always there and we always use the smaller number, but we may get the situation that we have to switch. So switching the bound of the integrations, you see if this is going to be integral from A to B, the natural one. But if you want to switch it from B to A, so you get the opposite. So the opposite would be negative integral from B to A, f of x dx. Okay, so if you have to switch your integral limits, so you have to pay for it. Opposite number, opposite sign. Okay, any question? So, you have a couple of them in your assignments that they give you this, they say, oh, integral from A to B is equal to 10. What is the integral from B to A? You say, oh, B to A is the opposite of the first one. So if this is going to be 10, the other one would be -10. Okay, so this is another property that we use. Now this next one would be very important for us. What is this next one? You see, we can find this integral so far. If the function is going to be continuous, it's guaranteed. But in application problems, especially in the problem of the probability, you may have a piecewise defined function. Remember the piecewise defined function? The piecewise defined function, you define the function in different steps. Okay, 1, 2, 3, etc., like the post office function. You see, you have different, like when you pay your taxes. When you pay your taxes, there are going to be brackets, range. So, the range of the income between up to the $34,000, $35,000, you've paid 10%. So you may have to integrate in different ranges, if you like. So in order to go from A to B, you may have to break it for the piecewise defined function. You can do it. If you want to break it, this is going to be the integral that we're going to have. Okay, before I writing down, I just just give you a graph so that you understand it. You see this is going to be the one. You see, if this is going to be the area under the curve that you want to find, and this is going to be your A, and this is going to be your B. Okay, and this is going to be your B. So the situation they're going to have, you may have to break it, or you may like to break it. You see, you pick a point C here. If you pick the point C here, you divide this region in 2 parts. You see, this is going to be the first part, and this is going to be the second part. So naturally, now if you want to find the area under the curve, or the integral of your function is going to be the area of the first one plus the area of the second one. So the area of the first one would be integral from A to C, and the area of the second one would be integral from C to B. And that would be very, very important. Okay, so this is going to be the case. So the integral of A to B, f of x dx. If you like to break it, yes, you can do it. It's going to be from A to C, f of x dx, plus C to B, f of x dx. You see, that's going to be 1. So this can be true for any number. So it's true for any numbers. They usually say C between A and B. It doesn't matter really. Any numbers like A, B, and C, or any number for any, if you like it, like in your book, any number C between A and B. It doesn't matter if you give me 3 numbers, I can write this one all the time for you because of those switching that you're going to have. Okay, so this is going to be used in the problem that you may have to integrate in science, and those functions are piecewise defined function. So you have different steps. So if you have a different steps, so you can break it to get this, this true. Now, the most famous example of this one is the absolute value function. So I'm going to give you that example. Okay, any question? Everything else is going to be right, the one that we did before, but this is going to be the one which is different. Okay. So the best example, you have a group of them in your book. And the best one is how we're going to deal with the absolute value. Remember, in calculus, anytime we have the absolute value of function, we're dealing with something special. So we did it for the limit, receive the derivative, now for the integrations. So this is the example. You want to evaluate. Okay, evaluate integral from 0 to 2, 0 to 2, absolute value of x minus 1, dx. You see, you have a number of them in your book. You know that as we did it before taking integral or any formula, you have to take care of the absolute value. You have to drop it. Otherwise, you cannot use any formula. Now, you know that you cannot drop it right away. So how are we going to drop it? We have to check what is the sign of the inside, as we did it for the limit. If the sign of the inside is positive in this interval from 0 to 2, if it's positive, you drop the absolute value without taking any action. But if x minus 1 is going to be negative, then you drop it, but then consider opposite of x minus 1. Remember, minus x minus 1. So the question is going to be, which one is it? So you look at this 0 to 2. You see, this is x minus 1. So the situation is going to be, you see, this is the way you're going to think about it. X minus 1. You see, this is 1. This is 1. X minus 1 means, you pick an x, you can pick the x here, or you can pick the x here. Okay, this distance could be x minus 1 all the time. Or this distance, you see this distance over here, the distance. The distance is going to be absolute value of x minus 1. And this would be absolute value of x minus 1. Because the direction is different. Okay, for example, from Oceanside, let's say to San Marcos, it's 12 miles. It's the same from San Marcos to Oceanside, but the direction is different. Okay, so now you think about it, that what is going to be the sign here? You see, if you are here, your x is bigger than 1. So for example, x is 1.1. If x is 1.1, 1.1 minus 1 would be a positive number. So you drop the absolute value. But if you are here, x is less than 1. Like x equal to the 0.9. 0.9 minus 1 would be negative 0.1. It's a negative, but the absolute value make it positive always. But what's the interval that you have? 0 to 2. So this is 1. So this is 0, for example. You see, this is, suppose this is 0, and this is 1, and this is 2. So you want to integrate over here, you see, between 0 and 2. Since you want to integrate between 0 and 2, you can't do it right away, because your numbers can be to the right of the 1, or maybe to the left of the 1. So that's why this integral 0 to 2, you cannot do it right away. But we can do it if you break it between 0 to 1, 1 to 2. Because if you are between 0 and 1, this is negative. If you are here, x minus 1 would be positive. That's the application of that formula that I talk about it. Okay, so this integral is 0 to 2, because 1 is between 0 to 2. So what we're going to do is, for the solution, you break the integral. You say, oh, integral from 0 to 2, the absolute value of x minus 1 dx is equal to, it's going to be 0 to 1, absolute value of x minus 1 dx plus 1 to 2, absolute value of x minus 1 dx. Any question? So this center number, if you like, you see x minus 1, if you let it equal to 0, x would be 1. So the center is 1. And since it's 0 to 2, you have to break it to get these numbers. Okay, if it was something like, if it was something like, let's say, not 0 to 2 over here, okay? So if you want something like between 1 and 1.1, you know that you are going to be in this part, or something just over here. But the given number is going to be around the 1. Since it's around the 1, you have to break it to get these two parts. Any question? Now we know that if you are going to be in this interval between 0 and 1, 0 and 1, you see, so your x is less than 1, so this would be negative. You see, this is negative. If you're going to be here, this would be positive. And that will, that will help you to integrate it. You have to integrate it separately. So you take the 0 to 1, absolute value of x minus 1 dx. Now, I just remind you, this is just for your information. You don't have to write it when you do the problem. In this case, we say that in this part, you see 0 to 1, x is less than 1. When x is less than 1, this absolute value of x minus 1, and the inside would be negative, so this would be opposite of x minus 1. You see less than 1 means you are here. So you are going to integrate 0 to 1, negative of x minus 1 dx. And this is very easy to find. Apply the negative sign, is a negative x plus 1 dx, and integrate it. So the integral would be negative x squared over 2 plus integral of 1 is x, to be evaluated from 0 to 1. So if you put the 1, that gives negative 1/2 plus 1. Remember, minus, if you put the 0, that gives you 0. So the result would be negative 1/2 plus 1. The result is 1/2. So the integral of the first one would be 1/2. Any question? We do the same to do the second part. So what is going to be the second part? The second part, integrating 1 to 2, absolute value of x minus 1 dx. But this is 1 to 2, means x is greater than 1. It's just for your information. So, oh, x is bigger than 1. So x minus 1 is positive. So I don't need any absolute value. So that would be exactly x minus 1. Okay, so the result is integral from 1 to 2, x minus 1 dx. You see the difference is going to be just the negative sign that you got over here. Now integrate it, which is x squared over 2 minus x again. It got to be evaluated from 1 to 2. Substitute. If you substitute, that give you 2 squared. Okay, 2 squared over 2 minus 2 minus, open up the parentheses, replace x by 1. So that give you 1/2. Okay, 1/2 minus 1. Any question? So 2 squared, 4. 4 divided by 2, that gave you 2. So that would be 2 minus 2. And inside minus, okay, you can subtract it or just simplify it first. So that will be minus negative 1/2. So these two would cancel out, and negative positive. So that give you 1/2 again. Okay, so the both part give you 1/2. Now you add them together to get your integral. Okay, so and the integral from 0 to 2, absolute value of x minus 1 dx is going to be the first part 1/2, the second part 1/2. The result would be 1. That would be the final answer. Okay, as I told you, this method, you may not see it quite a lot in this course, but it's going to be used for piecewise defined function. And this is what you do in science, because the function would be given to, remember the function would be given to from 1 to 2, 2 to 3, 3 to 4. So if you break it into different parts, so when you want to integrate it, you integrate each part separately. You see the first part, the second part, the third part. In those cases are easy if the function are given, but the absolute value is the one that you have to check it yourself. It's around the 1, so you break it in 2 parts to get this final answer. Any question? So that's the first topics of this type of integration. It's going to be very useful in calculus too. We use it quite a lot over there. Now, this is the first group of the property. Now, the second property, which is much, much more important, and we give one question on that one, on this test and on the final. What is that one? You see these integrals that I did so far, they are all nice. All nice, and since we said that, let's see, look at this one. We said that if f is continuous, this integral does exist. So this means you can replace f by anything you like. Yes, you can replace f by anything you like, and that integral does exist. But the question is, can you find it? You see, there are some integrals or some definite integral in science that be used quite a lot, but we cannot find it by just using this type of method. We can estimate it with calculator, but we cannot do it right with this type of formulas to finding the, to finding the antiderivative and do it. These type of integrals are going to be referred to it as integral functions, and they are quite important in physics, statistics, biology, etc. So we want to now give you an idea of what's going on with this and how we're going to use it in science. This would be a very easy question, but some people, they miss it. Don't have a good idea of this type of function. So we practice so that you are not going to lose it really. That would be a very easy question to answer. And this is the one that you use in future, okay? So this is the other property of the definite integral. I'm going to take it out, talk about it separately, because it's very important property. So the notion is integral, okay, integral functions. What is integral functions? Okay, so we start with this one. So remember the different names that we do when we say a radical function. This means the function is defined by a radical. When we say trigonometric functions, so the function defined by trigonometric function, sine, cosine, etc. Integral functions are going to be functions that are going to be defined by an integral. But that integral is not possible to evaluate. Okay, so let's give you the definition of the integral function. So suppose, okay, suppose f is a continuous function. F is going to be a continuous, okay, continuous function given on a closed interval, well, a and b. Okay, when it's a continuous, it's guaranteed that the integral of a to b f of x dx always exists. We have no doubt about it. So suppose f is a continuous function. Now I'm going to introduce another function, and a function is the next one. I'm going to use a capital F for these. Okay, it is also defined. Is going to be defined by this formula. Look at the definition of the function. F of x is equal to integral from a to x, f of t dt. This is going to be true for all x, in the closed interval of a comma b. You see this function? So what does it mean? This is, suppose if you want to find f of 1, so you have to put the 1 here. Then you have to go and find this integral. You find the integral from a to 1, then that gives f of 1. If you come back and you find f of 2, so replace x by 2, you have to find the integral again and again and again. Okay, since it's defined by integral, it's going to be referred to as an integral function. Okay, f is called an integral function. You see, that's the one. Of course, this function is such that you may not be able to find the integral. But since your function is continuous, you know that this is always the case. Okay, so they refer to this one as an integral function. The first observation that you can have is if you replace x by a, so what is going to be f of a? Note that if you want to find a function at a, f of a, so that would be the integral from a to a, f of t dt. I'll just use the t here because I already got the x here. That's why. It doesn't matter really. Okay, but remember we talked about it. Integral from a to a. You don't move, you don't get anything. So the integral from a to a would be 0. So it doesn't matter. 2 to 2, 0. 5 to 5, 0. And so that's the first observation that you have to take into consideration. So consider this one all the time. So f of a for this function is always 0. So this means if you match the top and the bottom, the integral is 0 automatically, and the function is 0. But if you have any other number, you have to find it. If you replace x by b, that gives you integral from a to b, f of t dt. Then you have to go and find this one. You have to go and find the integral and replace the a by b. Okay, so this is your new function. We call it integral function. Okay, let's give you some examples to get to know them. They are very famous. And don't try to, let me just write it down, then I give you the warning. So these are going to be the integral function. So far, the best one are from a statistic, exponential function we talk about later, because we talk about the exponential function next week. So we have to give you other type. And this is it. The first one, f of x equal to the integral from 0 to x. The top is t. The bottom one is 1 plus t to the 4th. Okay, dt. Look at this one. This is integral function. Why we call it integral function? Because it's defined by an integral. And this integral is t over 1 plus t to the 4th. You cannot find it. But you know that it does exist because this function is continuous. You know that the rational function are not continuous when the denominators happen to be 0. But this denominator is never 0. So it's guaranteed that this integral always does exist. But don't try. I've given this one on the test for something else. Some people try to find it. You can't do it. You can't do it at a specific number. You can use calculator. So this is we call integral function. So it's a function that's defined by an integral. So if you want to find f of 0, that's easy. F of 0, 0 to 0. 0 to 0 is 0. But if you want to find f of 1, 0 to 1 t over 1 plus t to the 4 dt. You have to use calculator. You can do it. You see, if this is going to be the case, this is the one. So f is an integral. F is an integral function. Integral function with the only thing that you can do firmly is f of 0. F of 0 is equal to the 0 because the 0, 0. Okay, f of 0, just remind you again, 0, 0, t over 1 plus t to the 4 dt is equal to the 0. Or any other number, okay, so for example, if you want to find f of 1, so that would be 0 to 1, t over 1 plus t to the 4th dt. You can't do it. You can only use your calculator to estimate it. Use a calculator to estimate it. Okay, so that's why we call it integral function. Integral function is a function that's defined by an integral. But in a minute, we'll see that the way we're going to use it in science, we don't care about whether we can find it or we cannot. Okay, any question? So if you see, don't try to find the integral. I'm going to tell you what we need to do with it. That's type 1. The type 2 that I just want you to see them. Don't try to find them. The best one coming from physics, and this famous function, I've changed it a little bit, of course. It's I already talked about it. We call it Fresnel integral. Fresnel integrals. They're going to be used in physics and quite interesting. And they are going to be integral of a sine of the x squared, or the cosine of the x squared, or the radical x. I just use one of them here. So check on internet for yourself. You see quite a lot. Okay, so our example is this one, f of x equal to. You may have something extra, x squared plus integral of 0 to x sine of, sine of radical t dt. You see, this part is Fresnel integral, this one. But just something else added so that you know that when using in science, you may have something extra. No worry. You see this function? The outside is x squared plus an integral function. So again, this is going to be integral function. Don't try to find this integral, it's not possible. You can only estimate it. Okay, so this is going to be, again, f is an integral function. Integral function. Again, with, you see, f of 0. If you want to find the f of 0, it's going to be 0 squared outside. And for the integral, it's 0 to 0, sine of the radical t dt. But we know that integral from 0 to 0 is 0. And this is 0 as well, so that would be 0 too. So f of 0 is equal to the 0. Okay, so this is another type. Question? There's another one that's impossible to find. This one, f of x equal to integral of from pi half to x. Pi half to x, cosine of the t over t squared, dt. Again, you see this function, the inside one is all continuous. This is also continuous in this interval. You know that it's not going to be continuous when t is 0, but you start with the pi half. So this means the function is continuous, so this integral is possible to find, but we can't do it. We can't do it, with the usual techniques. But a specific number, again, we can use a calculator to do it. So that's why we call this one integral function. So f is an integral function. integral function. And the only thing easy one for you is if they ask you to find f of pi half things. F of pi half is equal to, this would be pi half, x is here, pi half cosine of t over t squared dt. But you know that pi half, the integral is going to be 0. So in this case, f of pi half is equal to the 0. Okay, if they give you a number, if you just match these limits of integrations. But if you want to find anything else, you have to use calculator. Okay, if you want to find what is f of pi 4, sorry, this is the pi half. Okay, so suppose you want to know what's going to be f of 2 pi third, 120. So this would be the integral from pi half to 2 pi third cosine of t over t squared dt. You can't do it. You can only use your calculator. Use a calculator to estimate it. Of course, there are other methods to do it in calculus too. We have a method, we call it power series. We can use the power series representation to do it right away. But again, that result would give an estimate. You are not going to get exact number, okay, for this solution. Okay, so I just want to get a good feeling of the these type of functions that we're going to have. Any question? So what's the use of these functions that we use it in science, okay? So why we are very much interested in? We are interested in because in science, we are interested in what? We are interested in the rate of change, remember? Rate of change of the coronavirus, rate of change of your income, etc. And you know that the rate of change is derivative. So if this is going to be a model of some production, something that you have in your project, you may be interested in, you see, you do some some experimental work, and you will find out that your model would fit into these mathematical expressions. There are some ways we can do it. We find the model. This is the mathematical modeling. Now that you have this mathematical modeling, you may be interested in rate of change of whatever you do. Rate of change is derivative. So you are interested in the derivative of this function. Just think about it. You want to find the derivative of this function. So you have to find the derivative of integral. Just informally. What is the integral? In order to get the integral, remember you have to find the antiderivative, those formula. So to get the f prime, you have to find the derivative of antiderivative of a function. Derivative of antiderivative of a function. What's the result? Anybody can guess? Informally. Just think about it. What is the reciprocal of the reciprocal of 5? Any suggestion? What is the reciprocal of the reciprocal of 5? Anybody? Yes, we have one answer. Checking. Yes, Evelyn, you're right. 5. Reciprocal of the reciprocal of 5, you get 5 because you know you do the opposite of the action. Because reciprocal of 5 is 1/5 and the reciprocal of 1/5 is 5. It's like what is the opposite of the opposite? Okay, opposite of the opposite of -4, if you like, or of 4. So that gives you the same number. It's the same thing over here. So when you want to differentiate this function, you want to find the derivative of antiderivative of a function. So derivative of antiderivative of function must be function. Is there something natural? derivative of antiderivative of a function. So if you want to find the derivative of the integral, the result would be a function. So this simply means you drop the integral, derivative would be cosine of x over x squared, and you're done. You see, it's very informal. It's a great theorem. It was proved by Cauchy, Agustin Cauchy. So that's why we are interested in this type of function. Because although we cannot find this integral, we don't care. Because we are interested in the rate of change. When you get the rate of change, which is derivative, we lose the integral and we get a function. You know that when you have that function, it's a rate of change. You can do whatever you like with it. You like to find the maximum and the minimum of the function. You know that you have to find the derivative that is equal to 0 to get the critical point. So as soon as you differentiate it, you lose the integral and you can do critical points, find where this function will be increasing, decreasing, and you can have the second derivative. When you get the second derivative, then you can talk about concavity, inflection point. So everything would be fine. Everything would be fine from that point of view. That's why if we do some mathematical work and we arrive at this function, we are not going to be worried about it. We say that, oh, I give you the solution as an integral function, and you take it and do whatever you like to it, okay? So that's why it's very crucial to connect it to the derivative. In fact, it's the way that you are going to find a, create an antiderivative for a given function. Okay, so this very informal result that the derivative of antiderivative of a function is a function, it's a great theorem. We call it it's the Cauchy theorem, Agustin Cauchy. In some calculus book, remember the way I proved the fundamentals of calculus for you, I didn't use anything other than the mean value theorem. In some calculus book, they use this idea that we have here to prove the fundamental term of calculus. That's why sometimes they say this considered as a part 1 of the fundamental term of calculus. There's no part 1, part 2, it's only one. But they like, so they switch it. Even in your book, they switch this one when they talk about it. But I did it the other way around because I proved the fundamental theorem of calculus for you without using these ideas. Okay, so let's put it into a theorem and then we give you that problem that we are interested in, okay? So this is very important, as I told you, function. There are famous one in calculus, in other discipline. We have a group of them. One of them is just for the normal distribution. It's used in a statistic. This type of function, we talk about it later. You have some, gamma function, alpha function, beta function. These are all the functions that are going to be defined by integral function, okay? So this is it. The informal result that I talk about it is very formal and very nice theorem. So this theorem, again, was proved by Agustin Cauchy, French name, Cauchy. And that's it. If f is continuous, if f, the function f, is a continuous function, it must be continuous, otherwise you can't do this theorem. Of course, you need the continuity to get that integral. If f is a continuous function on the closed interval of a and b, then the integral function that I'm going to introduce, integral function, that function, f of x, is a function that's introduced by an integral from a to x, f of t dt, like the one that we talk about. Okay, this function is differentiable now. Is differentiable. Is differentiable, and the derivative of the function and f prime of x, remember the one that we talk about it. You wanted to find the derivative of antiderivative of a function. The result is a function. So this means you drop the integral, replace the t by x, f of x for all x inside that interval. That's it. Great theorem. The derivative of, the derivative of an integral function is just a function. Okay, it can be, I can prove it for you, but I don't. Today you can use the definition of a derivative just to prove it. You see, definition, limit of f of x plus h, remember, minus f of x over h goes to 0. Then you have to use the mean value theorem again to be able to go through it. If you get time later, I talk about it, but otherwise we accept it. Okay, so that's it. We got the great tools. So we are interested in the derivative of the integral function only. So we give you a function and we ask you to differentiate it. Easy way to do it. Okay, as I told you, it's a rate of change. So we may talk about the first derivative or the second derivative. So let's get the example. And this is going to be that question from this section that I talk about it. One on this test and one on the final. Some people missed it. And this is your easiest question, really, that you may have. So I'm going to divide it in two parts, the part which is general and the part that we are going to be interested in. The general one is just integrating, find the derivative of each function, derivative of each function. The functions are going to be integral function. The first one, f of x equal to integral from 0 to x, t, over 1 plus radical 1 plus t squared dt. Look at this one. It's the integral function. Don't try to find the integral, it's not possible. What you are interested, derivative, differentiate. F prime equal to derivative of the integral function is just a function. So you drop the integral, replace the t by. Of course, this function is continuous. This function is continuous because the denominator is never 0. Since the function is continuous, then you can use the theorem that we talk about it. So solution simply is going to be solution f prime of x equal to, you drop the integral, replace the t by x. X 1 plus square root of 1 plus, 1 plus x squared. That's it. You're done. Derivative of the integral function is just the function. But the function must be continuous. The function is continuous and you're done. Question? Easy case. Okay, let's have another one. Another one is going to be number 2. Number 2. Number 2 having something like g of x equal to, we may have something outside as well, okay? Something like a 3x plus, 3x plus, that's it, 3x plus, let's say, 0 to x, 0 to x, and this is going to be radical 1 plus t squared dt. Again, you have something extra here, no worry, because the 3x derivative of 3x would be 3. So you have your integral part, the function inside is a continuous function. So we differentiate it as we go on. Solution, g prime, derivative of 3x would be 3, plus, when we get to the integral, we drop the integral, replace the t by x. So drop the integral, the result would be 1 plus x squared. That's it. You see, you have the g prime. You can You may like to do something else, so it depends. But in this case, you've been asked only find the derivative of the function. So that would be the derivative of the function. Any question? So these are mostly the ones we're going to be interested in. But in your book, you have a couple of problem which is special. What would happen if this x is going to be something else? So you have two problems in your assignment. Just explain. One function is this one. So I write down in red so that you know that it's different. G of x, for example, is equal to integral from 1 to x squared. 1 to x squared, this is sine of t over t dt. Let's see what is special about this one. You see, this is not x, it's x squared. You see, it's x, we get x squared. So this is you see, since it's x squared, it must be g of x squared than the x. So it's a composition of two functions. One function is integral function, and the other one is the u function. Remember, like the one we did for the ordinary function, if you like. So you have to use the chain rule. You know that when you use the chain rule, we differentiate it as we do it, but you have to multiply by u prime. So in this case, if you like, this is going to be the version of the formula would be, you see your g prime of x, you drop the integral and replace the f by u, for example, over here. Okay, but you have to multiply by u prime, chain rule. So when you want to do the problem in your book, so in this case, you know, the chain rule is available all the time, even for this group. Solution, g prime. Do the one that you did for all the other one. We drop the integral, replace the t by x squared now. It's going to be the sine of x squared divided by x squared, but you're not done. Since it's x squared, you have to multiply by the derivative of the x squared. So you have to multiply by the derivative of the x squared, u prime. Okay, derivative of x squared would be 2x. So this is going to be the sine of x squared over x squared times the 2x. So the x and x would cancel out. So finally, g prime of x is going to be equal to, there's an extra 2 on the top, 2 sine of x squared divided by x, because when you simplify it, there is a leftover here. Okay, so this is just when you want to do the problem on your book, you are going to pay attention to this one. Okay, so if it's anything other than the x, in the application problem, we have it only x all the time. But if there is going to be anything other than the x, you just consider it to be u. So the idea of the derivative of antiderivative would be a function is the same, but it's going to be replace the t by x squared. Then you have to multiply by u prime, which is going to be 2x. Okay, so this is the first group of the problems. The second one is the one we are interested in, that we do something else. So I give a break, we come back and we do the one that we are interested in for the application problem and mostly for the test. Okay, so then we finish this one. Okay, so it's almost 9:10, 9:07. Okay, so we come back about 10 or 15 minutes, then we do the other part. Okay, so come back at most at 9:20, 22, 25. Okay, see you then. Okay. So I'm going to give you one more of these examples, okay, especially the one that we are going to be interested in. In these problems that mostly you are going to see it on your book, they just give you the function and you just want to differentiate it. But we want to know the actual one that you may see in application in science. So a function, an integral function would be given, then you would like to work with it, okay? So try this one. Example. Because when we are in science, you know, this function f must be, you know, can be kind of a position function. Then the derivative, you know, the derivative would be rate of change, sometimes velocity. F double prime just give you the concavity or they may give you acceleration. So we're going to be interested in to see how we are going to deal with those type of situation when a function is an integral function. Okay, so this is our concept. There you are. Suppose the best case, of course, is exponential one that we talk about later. Suppose you have this function. Look at this function. F of x is equal to the x squared plus integral from 0 to x, and the square root of 1 plus t squared dt. This is your function. Okay, this integral is not bad. Even you know, in calculus 2 you can find it, but not for the moment. What they are going to ask you is how we're going to check or how we're going to operate with this function is derivative and the second derivative. So we are going to ask you find one situation. What's going to be f of 0? Okay, what is f prime of 0? And what is f double prime of 0? Okay, three cases that we are interested in. Function itself, okay, the derivative rate of change, and the second derivative or the acceleration or concavity. Okay, so there you are. Again, it's integral function. We cannot change it, so we take it as is. So this is going to be the solution. Okay. For the solution f of 0, just replace x by 0 wherever you see it. So it's going to be f of 0. You see x equal to the 0 here. So just substitute. It's going to be, I write it down so you know that, is 0 squared. It's going to be plus integral from 0 to x, but x is 0, so it's going to be 0 to 0. Okay, and you have the radical 1 plus t squared dt. You see that's one. The integral part, you see 0 to 0. We talk about it. If these two numbers are going to be the same, so this integral is always 0. So that gives you 0. And the other part is also 0. So this is simply is going to be 0 plus 0. And 0 plus 0 is 0. So f of 0 is equal to the 0, the first part. Okay, so the first part is simply a substitution. You substitute that integral part. They give you the number that they match. Okay, these two match, and then it would be 0 all the time. They are not going to give you any other number because you can't do it, and we are not going to be interested in the calculator. So that leftover depends whatever it is. So in this case, f of 0 equal to the 0, that gives you the value of the function, and we're done. Any question? No. Derivative. You see, in order to get the derivative f prime at 0, you have to find f prime of x first. F prime of x. So let's differentiate. This is f of x, differentiate, f prime, f prime. Outside of the integral, derivative of x squared would be 2x. Integral, we talk about it. Derivative of antiderivative of a function is a function. So for the integral part, you drop the integral and replace the t by x. Okay, we're just using that Cauchy theorem. So f prime of x is equal to outside 2x, integral part, drop the integral, replace the t by x. So that gave you 1 plus x squared. That's your derivative. Okay, we're just using the theorem that I talk about it. Derivative of x squared 2x. Derivative of integral. Derivative of integral is just a function because it's opposite operations. So that's f prime of x. But what you want? F prime of 0. So replace x by 0. So that gives f prime of 0 is equal to the 2 times 0 plus the square root of 1 plus 0 again. So 2 times 0 would be 0, and this would be radical 1, and the radical 1 is 1. So that gives me 1. So f prime of 0 is equal to 1. You see? See, we didn't have the function in details, but we are interested to find the derivative of the function. And so, you know, the derivative can be used as the slope of a tangent line. You can write the equation of a tangent line. It can be used as the rate of change. So it depends on what you want. Any question? So that's a derivative. Now we want to know how you operate the second derivative. F double prime of 0. So you have to find the f double prime of x first. This is the part that you actually differentiate for us, okay? So for the last part, you bring your function. This is your function. You have to differentiate it. Of course, it's a radical function. You switch the radical. So this is how you start. You say f prime of x is equal to the 2x plus 1 plus x squared to the half. Now differentiate. For the second part, of course, you have to use the chain rule. So differentiate f double prime of x. You may use, in this case, use the quotient and use the chain rule. And you may use, quotient rule, any other rules that we talk about it. So we are ready for it. Derivative of 2x would be 2. Okay, that's it. Derivative of 2x would be 2. Now this one over here, you have to use the chain rule. So the chain rule that you need is u to the half. Okay, and you know that you bring the half down, 1/2 u to the negative 1/2, but you have to multiply by u prime. So in this case, is going to be 2 plus, you bring the half down. So it's a 1 plus x squared to the negative half times the u prime. U prime is a 2x. 2x, we can simplify these two. So f double prime of x, f double prime is going to be equal to the 2 plus x times 1 plus x squared to negative 1/2. Okay, but you want it at 0. So it's going to be f double prime of 0. F double prime of 0 would be 2 plus 0. Everything would be 0. You don't have to continue. Okay, it's going to be 0. And this is 1 plus 0. So this would be simply 0. So it's equal to the 2 plus 0, which is equal to 2. So f double prime of 0 is equal to the 2. Okay, so as you can see, it's a this is the way we are going to use this type of function in application in future. Okay, so it's a function. So you should be able to operate with this function. You should be able to find the value of the function, differentiate it. When you differentiate it, you got to be careful the fact that you drop the integral here. You get the radical 1 plus x squared. The only time that you really differentiate is when you want to get that, okay, f double prime. Depends on the nature of the function, what type of function is given to you. You may use the chain rule in this case, or in the practice one that we are, we are going to have, and we are going to check it tomorrow. You may have to use the quotient rule, okay? But we are ready for it. And that's it. That's this integral function. Any question? So in future, you are not going to be surprised when you see some results, some functions in terms of the integral. You remind yourself that's the integral function. And you do quite a lot. If you continue to take calculus 2, you use it. And calculus 3, then there is a course we call differential equation. And in that course, you see a number of these type of functions. Okay, so this is it. This is the integral function. Any question? Now there is one more topics related to the definite integral, and that's again a very important one. We call it average value of the function. That average value, in some books, they talk about it at the end of this chapter, or in some books like yours, they talk about it right away. So we're going to discuss it, but on the coming test, you don't have any question on the average value, but you are going to get one on the final. It's very important quantity. Okay, so let's see what's going to be the average value of a function. Quite interesting and many application in science. Okay, so what is going to be average value? Average value of a function. Okay, average value of a function. Let's see, what does it mean? You see, for example, today we ask what is the temperature today? And they say the average temperature today is going to be between now 72 and 85. So the question is going to be how they decide or how we're going to find these average values. You see, the term average, if I give you 5 numbers, if I give you 5 numbers and ask you to find the average of these 5 numbers, how are we going to do it? Any suggestion? If 5 numbers would be given to you, how are you going to find the average of that 5 numbers? Any suggestion for the term average? Anybody wants to try? We give you 5 numbers and we ask you for the average of that 5 numbers. Anybody knows how we're going to find it? Okay, if you want to get the average of 5 numbers, you add the numbers together and you divide by 5. That's it, that's the average. Okay, so if I give you 10 numbers and I want you to find the average of 10 numbers, you add them together and you divide it by 10. But the question is, if you want to find the average value of a function. So if I give you a function, let me just explain it as I write it down for you to see why we need this idea of a definite integral to be able to do it. Okay, so there you are. Suppose let's have a function on a closed interval to explain it. Suppose f is a continuous function. F is a continuous, okay, continuous function. It's defined on closed interval, on the closed interval of a comma b. Okay, so that gives you the function. Then you see the range of this function. So the range of the function means the values of the function. You put them together to get the range of the function. So the question is going to be, let me just, the range of the function, you know, you have to see how many numbers are going to be between a and the b. You see, if a is 1 and b is 10, how many numbers are going to be between 1 and 10? Infinity many numbers. Okay, so then the range of the function, the range of a function f is going to be all numbers that are going to be all numbers between, okay, between f of a and f of b. That's how you find the range of the function. Okay, so you have the domain, and so this means that this is going to be the range of the function. This is f of a, for example, and this is f of b. It depends on the nature of your function. You may get f of a, f of b, or you may get f of b, f of a. It's going to be an interval. So the range of the functions are numbered here. So how many numbers do you have? You see, quite a lot. So there are infinitely many numbers between f of a and f of b. So you cannot find the average of those infinitely many numbers in calculus 1 or in general. Okay, so we note that there are infinitely many numbers. Okay, there are going to be infinitely many numbers in that interval between f of a and f of b. So means you can't do it. So the question is going to be, what is the average? What is the average? Okay, the average of those numbers, those values. Okay. So it depends what type of function you have. If the function is going to be a temperature function, and this is going to be for the last 12 hours, for example, 24 hours, interval between 0 and 24. So you have the distribution of a temperature at any time. So the question is how they tell you that the temperature today is going to be between 76 and 82, how they find out. Okay, so the question is going to be, as I talk about it, if we have 5 or 6 or 10 or 100 numbers, we can do it, but you have infinitely many. So how are we going to do it? This is where we are going to bring the calculus. So bringing the calculus means we are going to estimate it. So this is what we do with the calculus. You see, we say that, and note that, you see that interval, the domain, the difficulty is this domain that you have. So look at the interval of between A and the B. This is it. The reason that you get infinitely many numbers here, because there are infinitely many numbers between A and the B. But what we can do is, we can partition it. Remember the partition it? Divide it into equal parts. You see? Partition it into equal parts, like the one that you did for the integration. Now, how many numbers do you have? I'll call this one x0. So this is x1, x2, x3, up to the xn over here. Now, what we do is, we go inside each of this interval, and we pick one representative. Instead of considering all the numbers here, I go inside, I pick one out. I call this one C1. Then I drop it into the function, and I find f of C1. That one person or one number is a representative for the first interval. I do the same for the second one. I go inside the second one. I pick a number, I call it C2. Then I drop it into the function. I call it f of C2. And I continue. See, continue taking different representative. That. So finally, my representative would be Cn, and I pick f of Cn. You see? Instead of considering all the values between f of a and f of b, which are infinitely many, so now I have how many numbers? You see, I have n numbers. I find the average of these numbers. What is going to be the average of these numbers? I add them together. You see, I add them together. Then I divide it by the total number, which is n. This is the kind of average. Okay, I can take this one as the average of the function. But since it's not an exact, this is not going to be the same. So it's going to be kind of an estimate. So this would be almost like the average. See the way we write it down? Average value of the f function. Okay. So this is going to be one way to do it. So I just change it to the n number. We can write this on into sigma form to make it easier to handle it. Okay, so far, these are just the motivation to get this definition eventually. And so the average value of f is almost the top. You add them together, sigma of f of ci, I from 1 to n, and divided by n. Okay, this is the way you got it off here. But how we're going to make it, you see, how we're going to make this number better and better. You see, you can make it better and better if you increase this number of the partitions. You see, if somebody divide into 5 parts, you just get 5 numbers. But if you divide to the 100, so you get 100 numbers. If you divide to the 1,000 parts, you bring 1,000 numbers, 10,000 numbers, 1,000,000 numbers. So if you would like to cover everything inside, so you have to increase this number of the partitions. When you increase it, this means you increase the n in the language of calculus. This means if this n goes to infinity, that gives you the best value for your average. So this means it's natural, it's wise to say that the average value of the function must be the limit of n goes to infinity. Okay, limit of n goes to infinity, that sigma of f of ci, I from 1 to n, okay, over n. Okay, so what I did, I increased the number of the partition, so I will have more numbers. So this seems to be a reasonable definition for the average value of the function. But of course, this is not going to be easy to find because it's a partitioning one. So what can I do? The way we can extend it, we can relate this one to the integral. Remember, if you want to relate it to the indefinite integral, you need a delta x here. If you have a delta x here, then that would be integral. But what was the delta x? You see, what is the delta x? Note that. Remember, delta x was b minus a over n. So that would be b minus a over n. Okay. So I've already got the n here. So I need a b minus a to make it as a, okay, to make this one as the delta x that I need. See, I need the delta x here. So what I'm going to do in LibreOffice algebra, I'm going to multiply and divide this one by b minus a in order to get the result. Okay, go to the next page. I wanted to see the formula. I can write it down and you memorize it, but it's nice to know. So the next step is just doing a LibreOffice algebra to write it down as a nice formula. So this is it. This is the average value of the f. So what I'm going to do, I'm going to divide the formula by b minus a. Then I had the limit. Remember, that was a limit. N goes to infinity. So the sigma that I have, you see this is going to be the sigma r, f of ci. I multiply this one by b minus a. because I have a b minus a over here. They cancel out each other. And then the bottom one is simply n. And this is I from 1 to infinity, I to the n. But look at this one. Remember, this is simply delta x. So why I created? Nice formula. I create the average value of a function is equal to the 1 over b minus a limit of sigma f of ci times delta x, I from 1 to n goes to infinity. And you know that this is exactly the Riemann integral. Okay, so this part is just the Riemann integral. It's integral from a to b, f of x dx. So I arrive at the formula. Average value of a function is simply 1 over b minus a, integral from a to b, f of x dx. You see? That's the average value formula. Just prove it for you. But you don't have to know, you just have to know the formula. So that's another famous application of the notion of the integral and that partitioning one. Remember, I told you that you have to know the procedure because this is the procedure that we are going to use in application problems. Okay, so now we are going to make it official. We write it down this one as a definition. Okay, so this is the one that you have to memorize or make sure you bring it if you want to add it to your formula sheet. This is the one. You are not going to sit on this test, but on the final. We put one on the quiz 4. Okay, so there you are. The conclusion of everything I did for you is this. If a function, it's nice to know really, not just to memorize everything. That's why I did it. So if a function f is going to be continuous, or we say integrable, means we can find that integral, is integrable on this closed interval, then the average value, of your function of f on this interval, on interval of a and b, is defined by what? Average value of f is 1 over b minus a. Remember, it's different from the integral. You have this, some people on the test, they missed that 1 over b minus a. Is 1 over b minus a integral from a to b, f of x dx. Means you integrate it, then you divide it by that b minus a, that give you the average value. Okay, you memorize this formula. So the function would be given to you, just integrate it and you get the results. There are 2 types. You may have to use the substitution method, and they give you a shortcut for those type of problems in calculus, okay? So I need to give you an example, but I wanted to say another observation really, that to see that there is something else inside this. Remember the mean value theorem? So this is just for your information. If you like more details, or if you are going to be math major in future, just look at this. You see the way we find this integral is going to be, the way you do it is this one, remember? Use the fundamental of calculus. So the way we do it, to find this integral, you know that we find the antiderivative and we evaluate it at b and a. So if you put it here, so what's going to be your average value? Average value of f is going to be what? It's going to be f of b minus f of a over b minus a. Remember this one? According to the mean value theorem, there is a c such that this is going to be f prime of c. But in this formula, f prime and f of c are the same. So that give you this result. So this means the average value of f is going to be the same as that f of c that we find in the mean value theorem. You know, in some books they write this one and they call it mean value theorem for integral, but there is only one mean value theorem. Okay, so this means the average value is always possible. And there is a C between, okay, C is inside A and B. So this means this procedure that we did always give you the result. And it makes sense to call it average value. Remember, that's coming from the mean value theorem. So it makes sense to connect these all together. Or you see it in your book. This is going to be the conclusion they're going to have. Okay, so we are done. We need 2 examples on this one. One of them is just straightforward. The other one is applications. Many applications of this in science. And I give you a shortcut for that. Okay. And then we're done with chapter 5. And we are ready for the, okay, your practice quiz, practice test number 3, and we go for it. Okay, any question? So let's give you an example. 2 types, a straightforward one. We are interested in the application types, but let's check. Example, straightforward, a function would be given. They ask you to average value, find the average value. See, find the average value of this function, of the function. Okay, of the function f of x equal to 6x squared minus 8x plus 3 on this interval, on the interval of 1, 3, close interval of 1. That's it. That's a straightforward. Just write the formula, take the integral, and you're done. Most of the problem in your assignments are of this group. Solution. Okay, are you ready? Formula first. Average value of the function is, I repeat the formula, 1 over b minus a, integral from a to b, f of x dx. Make sure you have your formula. That's average value. A is the small number 1. B is the bigger number 3. So A is 1, B is 3. And the function is given to substitute. Average value of f is equal to 1 over b minus a, 3 minus 1. Integral of 1 to 3. Function 6x squared minus 8x plus 3 all dx. 3 minus 1 would be 2, so that gives you 1/2. Integral of 1 to 3, 6x squared minus 8x plus 3 all dx. Okay, continue. Integrate it. You know this is indefinite. It's a definite integral. We find the antiderivative first, and we evaluate it from 1 to 3. 1/2. Integrate. You know, we can put a bracket here. So that gives 6 times x, move up the power x cubed over 3. That's the first one, minus 8. The power is 1. You move it up, x squared over 2. Then plus 3, you know that integral of 3 is 3x. No constant c, but you have to evaluate it from 1 to 3. Okay, that's a kind of definite integral. Simplify it first, then substitute. 1/2. So you simplify these two, that give you 2x cubed. This would be 4 minus 4x squared, and the plus 3x to be evaluated from 1 to 3. 1 to 3. Question? Substitute 3 first. So it's going to be 1/2 times 2 times 3 cubed minus 4, 3 squared, plus 3 times 3. That's the first one. Minus, repeat it again for 1. 1/2 times, replace x by 1, 2 minus 4 plus 3. Okay, it's a definite integral. We replace x by 3, we substitute, then replace x by 1. Continue. Simplify inside each parenthesis first. 1/2 times 3 cubed. 3 cubed, 27. 27 times 2, 54. That's 1. 3 squared, 9. 9 times 4, 36. Plus 3 times 3 would be 9. That's it. Okay. Then we continue to get these numbers. What is this now? Minus 1/2. Minus 1/2. Inside, that's it. The 3 and 2 would be 5. 5 minus 4 would be 1. Okay, so this would be just times 1. Continue, simplify the inside. It's going to be 1/2 times. Okay, so you add these two together. It's going to be 54, and 9 would be 63. And the 63 minus, okay, it's a 63 minus 36, and that's going to be negative 1/2. Okay, so it's going to be 1/2 if you subtract this. Okay, so that's going to be, it's going to be 7, okay? And that's it, 27. 27 minus 1/2. So it's a 27/2 minus 1/2. So that gives it 26/2, which is equal to the 13. Okay, so the average value of your function. Okay, so the average value of your function is simply 13. Depends on what type of function do you have. And then we may have units. Okay, you may talk about dollars, miles, gallons. Then you get those average value. Any question? So as soon as you write your formula, for the rest is going to be just a definite integral type. Okay, that's going to be one example question. So would like to give you one application problem of this. In the application, you may have to use the sine, cosine, and you may have to go to the substitution method. So I give you a shortcut for those. Okay, it's, we can do it, but that would be useful, the following formula. Okay, so I'll give you this remark. You can use it anytime you like in this course. And it's going to be help you so much. Remark. You see, the remark is regarding the trigonometric function. You see, you can use the following formula, and you can use it on the test. You see, if you want to find the integral of a sine of, let's say, ax dx. A is a number. You can do it only for the number. You see, integral of a sine of 2x, 5x, 10x. You know that when you differentiate, you say that the derivative of a sine is cosine, you multiply by u prime. U prime derivative of the inside is a. But when you integrate it opposite of multiplication would be division. So if you want to find this integral, it's going to be equal to integral of a sine is a negative cosine. Negative cosine of the ax, you divide by a plus c, and you're done. Okay, because when you differentiate it, your prime is a and a would cancel out. Very good. Sine of 2x, 5x, 10x, that will help you. Otherwise, you have to use U substitution. It's clear. It's going to be used quite a lot. It's the same for the cosine. Cosine of the ax dx is equal to integral of a cosine is sine. Sine of the ax, but you divide by a. And it's true for the, okay. And so far we can do it with the secant squared of the ax and dx. Integral of a secant is secant squared is tangent. Tan of ax divided by a. And you can do it with the, but it's mostly with the sine and the cosine in application problem. But you can do it also with the secant tan. Secant of the ax, a tangent of the ax dx. So that gives you secant of ax divided by a plus c. There's going to be one case with the exponential function. We do it later. Okay, so that's option, but it would be useful for you to use it. Okay, now I can give you that application problem. So this is a very popular problem that if you want to find the average temperature of any city in America from the past, we have a kind of mathematical modeling for the temperature. So modeling means a function. Okay. So if you live in California, your modeling would be different if you live in, for example, Alaska. So the way they predict the weather for you, or they talk about the average temperature, they look into that model and give you what is going to be the temperature in your city. So I'm going to give you one of them, okay? And we give you one, we like this one. We'd like you to know the real application of the average value in everyday life, okay? So modeling in some area would be a little bit different, but this formula, the first one, is so useful for you when you want to find the average value. That A, I'm going to show you what's going to be the A in this case. Okay, so this is one of them. You have one in your practice one. It's quite popular. You can search on the internet and you get that average. You can take that temperature modeling of your city or any city to be able to find the average in everyday life. Okay, so there you are. In a certain city, you can say Oceanside, you know, San Marcos, it doesn't matter. So in a, we are not going to name the city if you like, but you know, check on internet from the weather channel, etc. You can find it in a certain city. Okay, the temperature. Okay, that's it. California in general. The temperature in degree Fahrenheit, T hours. Okay, T hours after 9 a.m. 9 a.m. was modeled by this function. So depends on the area that you live, you are going to have different model. We live in California, for example, so this is going to be the California model. That's it. Temperature. T hours after 9 a.m. is modeled by 50 plus 14 sine of pi 12t. It's going to be sine model, but this number would be different. Sometimes the one that you have in your practice one, you may have something extra in it. If you talk about Alaska, you know, the formula would be different. But these quantities are going to be there. I put it by 12, that's going to make it easy. So this is the model T hours after 9 a.m. So what do you want? You want to use this model to find what is the average temperature. So find the average temperature. Okay, average temperature. Average temperature during the day. Okay, during the period from 9 a.m. Okay, 9 a.m. to 9 p.m. Okay, during the day. We want to know what's going to be the average temperature. Nice example. Okay, and use that shortcut that give you the result right away. Now, first thing to do, you have to find the interval that we talk about it from 9 a.m. to 9 p.m. You see, from 9 in the morning to the 9 in the evening, it's 12 hours. So just remind yourself that the 9 a.m. to 9 p.m. is equivalent to the interval of 0 and 12. There are 12 hours between the 9 a.m. and 9 p.m. So what you would like to do is you want to find the average value. Okay, so we have to find the average value of a temperature function over this interval of 0 and 12. That's it. Any question? So you have the formula, substitute and find it. What is the average value for the temperature function? Average value of T is equal to, I give you the formula, 1 over B minus A, integral from A to B. You can call this one T of T because they talk about the time. Okay, we can use X as well, but they talk about temperature. So in this case, your A is the smaller number, which is 0. Your B is the bigger number, which is 12. Substitute, integrate. So average value of the temperature is 1 over 12 minus 0, 12 minus 0. Integral from 0 to 12, function 50 plus 14 sine of pi 12t, then everything dt. You see, this is going to be your integral. You have to find for us. Now 12 minus 0 would just 12. So what we are going to do is it's going to be equal to the 112. Okay, 112 integral from 0 to 12, 50 plus 14 sine of pi 12t. Okay, everything dt. So you have to find this integral. You can do it right away, or you can break it in 2 parts. It's up to you. You can break it to the one with the 50. Just do it and then do the integral part. Okay. All of them can be done, really together if you like. But it's up to you. Which one do you want to do? I do the breaking one for you, but you don't have to. So I break it in 2 parts. 1 to 12, because I want to use that shortcut for the second part. 0 to 12. 50 dt, that's the first one. And then 1 over 12. 0 to 12. Second part. 14 sine of pi 12t dt. Okay, so I break it into 2 parts. You don't have to. 1, 2. Okay, are you ready? Going to the next page, we find this one first. Integral of 50 is just 50t. Then you find it, and for the other one, you can use the shortcut that I talk about it. Okay, so there is a pi 12t, there is a t here. This is a t. Okay, pi 12t, pi 12t. Okay, so I find each part separately. It is going to be always a leftover, okay, that part that you have. So I do this part first, okay. The first part was 112, integral from 0 to 12. I have 50 dt. It's going to be 112. Integral of 50 would be 50t. 50t. But t going from 0. Okay, t equal to the 0 to 12. So it's going to be equal to, if you put the 12, that's going to be 112 times 50 times 12. And if you put the 0, everything would be 0. So in that case, 12 and 12 would cancel out. You get 50 for the first part. That's a 50. Any question? I just integrated. Integral of 50 is going to be 50t. Now the second part is our main concern. What was the second part? 1 over 12, 0 to 12. The function is 14. Sine of pi 12 t dt equal to, you see, you can pull this 14 out is a number. 14 over 12, integral from 0 to 12, sine of pi 12t dt. Now use the shortcut that I talk about it. See, this a is pi 12. Look at the formula. Integral of a sine is a negative cosine divided by a. So this would be 1412 as is, times it by what? Integral of a sine, negative cosine of what? Pi 12t divided by a, the coefficient of the t, which is pi 12. Then you have to find it from 0 to 12. You see that shortcut? Help you quite a lot. Otherwise, you have to do integration. You have to do substitution method here, which is messy, not bad. You can do it. It's going to be kind of messy to do it. Okay, and that's it. We are ready for it. Use the reciprocal of the pi 12, simplify and continue. 1412. Reciprocal 12 pi. There's a negative sign here. You can put it up in front. So that gives a cosine of the pi 12 times t going from 0 to 12. This 12 and 12 would cancel out. So that gives you negative 14 pi cosine of the pi 12t going from 0 to 12. Substitute is a negative 14 pi. You can open up a bracket and take the 12, replace the t by 12. So that gives you cosine of the pi 12 times 12 minus cosine of, when you replace the t by 0, that gives you 0. 12 and 12 would cancel out. You do cosine of the pi. So it's a negative 14 pi cosine of the pi minus cosine of the 0. Cosine of the 0 is 1. Cosine of the pi is a negative 1. So you get negative 14 pi times it by negative 1 minus 1. That gives negative 2. Negative 14 pi times the negative 2. So that gives 28 pi for the integral of the second part. Any question? But remember, we add them together. The first part is 50 and the second part is 28 over 5. So this means the average temperature during the 9 a.m. and the 9 p.m. of that city is the following. The first part 50 and the second part 28 over 5. Of course, you have to use your calculator. You cannot leave it and give us the final answer. So if you do it, the temperature is 59 degrees Fahrenheit. So that would be the average temperature in your city during the day. Very nice application. Okay, that's the main application of this average value. And it's a very popular problem, as I told you. It depends where you live. You can have the model for your place and then get the average value anytime you like during the day. Okay, so and this is it. So we finish chapter, chapter 4. We don't have anything else to talk about the integral. So tomorrow we practice that practice test, which is going to be important, will be repeated on the final again. And then the last week, okay, the last topic, there are going to be 3 sections of chapter 5 that we're going to talk about it. It's going to be exponential function, okay, natural log function, and inverse of the trigonometric function. So we finish all of them tomorrow, finish them on Monday and Tuesday next week before your, quiz number 4. Okay, so I study this one carefully, and then we go over the practice test number 3 tomorrow. That's it. Any question? Then that is going to be the case. Okay, thank you. Study it carefully. But no question from the average value on the test. But we give you the question of the integral function. I explain it tomorrow again. Okay, have a good one. Take care. Bye-bye.